Um, Welcome to our second chemistry lesson, the periodic table. And part two of this lesson will be periodicity, which is essentially trends on the periodic table. So let's get started. First, we have what is the periodic table? Essentially, it's the organization of all known chemical elements in existence. It's organized so that we can catalog and recognize where elements go and how they relate to each other in terms of chemical properties and physical traits. It's just really helpful in organizing the elements based on their properties.
The periodic table is primarily organized by increasing atomic number, which is the total number of protons in the nucleus of the atom. And these elements are organized into 7 periods, or they're called periods. They can be summarized as rows, and 18 groups, also in columns. And these periods and groups organize elements by their chemical properties to give us an organized look at the elements that make up our universe.
Okay, so the periods is the name for the row. Essentially, on the periodic table, there are 7 periods, and they organize elements based on the number of electron shells that they have. Essentially, on a single period or row, every atom has the same outer level, which is the valence shell. The amount of electrons that fill that outer level or valence shell increases as you go down the row, but each element in the period has that same outer level.
So groups, like the periods, elements in the same group on the periodic table have similar chemical properties. However, for groups, they generally have the same number of valence electrons. So unlike a period where the elements share the same outer level, in this case, they share the same number of electrons in the outer level.
And in general, groups have stronger similar chemical properties than periods. They're more similar than each element on a period would be. So that's something to keep in mind. So how do you read the periodic table? Essentially, every little box for each element on the table has this. So the top is just, the orientation varies, but it'll have the element name and then the atomic number, which is the number of protons in the nucleus, just protons. Then you have the average atomic mass, usually at the bottom. For carbon, it's 12.01. And then you have the symbol, which is just the shorthand abbreviation for the element name. And it's used in chemical formulas, equations, and just generally to refer to the element. So yeah, that's how you would look at a specific box on the periodic table.
So group 18 of the periodic table are called noble gases, and they're on the far right of the periodic table, and they are a very unique group because they actually have a full valence outer shell, and so they rarely make bonds with other elements. And due to their structure, they often are used in commercial lighting, and neon signs are an example of this.
The halogens, which are just to the left in group 17, they essentially lack 1 electron, as they are 1 to the left, in their valence shell. So this means in a valence shell that needs 8 electrons to fill it, like fluorine, it has 7. This makes them very reactive and electronegative. Essentially, they attract valence electrons from other atoms very strongly. And like I said, it makes them very reactive. And for example, chlorine is highly reactive and bonds with sodium to create salt.
The next is transition metals, in which they are all metallic, but other than that, the physical and chemical properties vary due just to the amount of transition metals. Compared to other elements, they have high boiling and melting points, but those again vary within the spectrum of transition metals. These elements have important commercial uses, like copper as an electrical conductor.
Okay, so the alkaline earth metals are all the way on the left in group 2. Essentially, they look metallic, at least physically, and they're good electrical conductors. They have two valence electrons, which makes them good reducing agents, which isn't exactly relevant, but it's just one of their uses. Um, they also are highly soluble in water. I don't know why, but that's just one of their unique properties.
Alkali metals belong in the first group on the left of the periodic table, and this does not include hydrogen. Each of these elements has exactly one valence electron, which makes them uniquely qualified to bond with halogens who are missing one valence electron. This is the case for sodium chloride, NaCl, or salt.
Okay, so that is the end of part one of this lesson. Join us for part two to learn more about the trends that go on the periodic table. Thank you for watching.